Right, guys, let's continue then. Let us try to continue in this. Now, in question 6, we have the following. They say, choose a triangle from column B that matches the congruent triangle in column A. Write only the letters A to D next to the question number 1.1 until 1.4. So let me show you what they have provided here. In 6, this is what we have, ne? We have a triangle here, and all three sides are not equal, right? And then we want to know this triangle is congruent to which triangle in column B, right? If all three, and now remember what congruency is about. Now, congruency is that all sides and all angles must be equal when compared to the other one, whereas similarity, the ratio of sides is the same. So in column B, I have a triangle. Let me see. Yes, so this would be congruent to number D. Why? Because D also, you have three sides that are not equal, so this and this would be congruent. So 6.1.1 is congruent, so meaning we are saying triangle NMO is congruent to triangle UVW. Good. And then we go to 6.1.2. we have this triangle. In this triangle, this is what is done, this is what is done, and we have just let me see what they have done here, this side, and then this is A, B, and C, right? So what are we saying in this triangle? Obviously this angle is not equal to that angle, so meaning two sides there are not equal. So which one will it pair with? Now let us try to check this. On the other side we have triangle C, and this is what we have. And look also here, look here, and this is what is done. And this one is called XYZ. So triangle ABC is congruent to triangle XYZ. And then in 6.1.3 we have the following. We have a triangle, a right angled triangle. This is not equals to that. We have an angle of 90, and this is called D, E, and F. So I'm going to check on the other side here, and then I have a triangle on the side which is also a right triangle, and this is what is done. So this is PLK. So triangle DEF is congruent to triangle PLK. And then lastly in 6.1.4 I have this triangle, which is RST, and this is the length of the hypotenuse, right? Let me see what it can pair with exactly with this one. So this one, we have an angle of 90. This is the hypotenuse, and this is another side. This is GHL. So triangle RST is congruent to GHL. Very, very important. Right, and then we go to 6.2. Now let us see what they want in question 6.2. We are given a right angled triangle, 0.3, 0.4, P, N, and M. Given that and an angle of 90, calculate the length of MP by using the theorem of Pythagoras, and 4 marks are provided for this. So Pythagoras says that PM squared is equals to sum of the opposite sides, PN squared plus NM squared. 0.3 squared plus 0.4 squared. Now remember, this is PM squared, and then you would square both sides. PM equals the square root of 0.3 squared 0.4 squared, because it is the length of the hypotenuse. So you will just complete that. In question 7, write down the trigonometric function sine, cos, and tan in terms of the given angles. Okay, write down the trigonometric functions sine C, cos B, and tan C. So sine C is opposite over the hypotenuse, which is y over r, sine of C, and this is what is provided to us. Let me draw this down for you. 62, that is C, 28, that is B, and A is 90, and this is 14. So sine of C, here we are at C. Sine would be, remember this is the angle of 90, so that is your hypotenuse. So sine is the opposite one is this. We are given this as 12.35. So sine C is opposite, which is 12.35 divided by the hypotenuse, which is 14. The cosine of B, there it is, cosine of B. Cos, it's the adjacent. Now remember, this is your hypotenuse, the side which is pointed by an angle of 90. So adjacent would be 12.35 divided by the hypotenuse of 14. And lastly, the tangent of C would be, let's look, see, there it is. The tangent of C would be adjacent, 10 its opposite, over adjacent. So the opposite would be 12.35 divided by the adjacent. 10 of C would be opposite divided by the adjacent. Now, do they mean that we should go and find this adjacent? Yes, we can use the theorem of Pythagoras to find the adjacent side, because that would be the opposite over the adjacent. You can just use the theorem of Pythagoras there to find the adjacent side. I honestly don't have an energy for that. Right. Question 7. I'm not going to do this. I'm a little bit tired. In triangle DEF, E is 90, DE 43, EF 72. Calculate the magnitude of sine F. I will need to draw up a triangle for this. So let me just leave it here. We will continue with question 7.